Hey there. Today we're going to start or look at 5.4, medians and altitudes. These are two new segments that we can draw within a triangle, but they do different things. Let's start with medians. This is maybe something that a term that you've used before, you've heard of. The median, I think of it like when you do mean, median, and mode. The median is the middle. So when you think of a median in a triangle, it always goes to the middle. So in this example, it comes out of a vertex and it's going to go to the middle or the midpoint of that opposite side. So we'll always know these two legs here are the same. Goes to the midpoint. Now when you draw in all of the medians in a single triangle, like in this example here, you can see that they've drawn all the medians in. They should meet all in one spot. That's called the point of concurrency. And that point of concurrency for the medians is called the centroid. Now we've learned some other terms for the other segments, but for a median, that's a centroid. And it has some special relationships. When you find that centroid there, that is always going to split the median into a 2/3, 1/3 section. So what I typically do is I'll take, all right, if this is 2/3, then I'll kind of find the middle of it and I'll put a dot right there, and then it'll break it up into 3 parts. All right, and that works on all the medians. Right here, this section would be 2/3, this would be 1/3. The other thing that's kind of cool about the centroid is it's considered the center of gravity, which means that if I were to find the centroid on like a big piece of paper or something on a triangle, and then I cut that triangle out, well, it's kind of floppy and it's a piece of paper and it would be hard to balance, like on the end of a pencil is what I'm thinking. If I were to try to balance that on the tip of my pencil, it probably wouldn't balance very nicely. Unless I put the tip of my pencil right at the centroid, the center of gravity, then that would balance nicely for it. All right, let's keep going. Let's look at some of the numbers that we'll deal with the medians. Now, remember the 2/3, 1/3 thing. So what I'm going to do is in this example, it tells me that XA is this right here. This is 8 units. But what I said I'm going to do is go ahead and put in there, put a dot kind of in the middle of it. Like right there. And what that breaks it up then, the centroid and that dot that I put in, that breaks it up into thirds. Now if they tell me XA is 8, well then I know that's going to be 4, that's going to be 4, and that's going to have to be 4. All right, now what you do then is you answer the question once you have that filled in. What's the length of XB? XB is the entire median, and so altogether that'd have to be 12 units. Okay, see if you can do this next one. Kind of the same deal. They tell you what ZA equals. You're looking for ZC. ZA right here is 9. Then I have the centroid, and then I have this other piece. All right, I'm going to put a dot right here to split that. Now it's broken it evenly into thirds. This segment is 9. So when I put that dot in there, I put it in the middle. So these are each 4.5, 4.5, which means this down here is 4.5. And then the question that they're asking is what's the length of ZC, which is the entire median. So 4.5 times 3 actually gets me 13.5. If you look at part B here, it says what's the ratio of ZA, well ZA was 9, to AC, 4.5. Well, you can write it like that, but there's a neater way to write it. I mean, 9 is twice as much as 4.5, so I could reduce that, and it'd be a 2-to-1 ratio. And that will always be the case, that the 2/3 chunk is twice what the 1/3 chunk is. All right, we're going to move on to the next segment then. So that was medians. Now let's look at altitudes. Altitudes, again, are something you should have seen before. You use them when you find the area of a triangle, when you do 1/2 base times height. The height is the altitude, and it is always drawn out of a vertex perpendicular to the opposite side. It doesn't necessarily hit the middle. You can see here that this is not the middle, but it is going to end up perpendicular. All right, from the vertex perpendicular to opposite side. Now, that's our fourth one, or actually that's the fifth segment that we've talked about. And so there's so many of them, we start to lose track what's what. I do have a little cheat sheet for you to help you remember what's what and which ones have a point of concurrency and all that business. But let's see what we can do with this. It says, in this triangle, each segment is a median, an altitude, or neither. We're supposed to decide. So looking at AD, if I look at the segment AD, and it comes right down here, and right here I notice that D is the midpoint. Okay, what's the segment that comes from a vertex to the midpoint? Right, hopefully you're saying, oh, that's the median. Okay, so then we would say that that's AD is a median. All right, now the next one, EG. This segment here, EG. That does not come out of a vertex, and so that's not one of my new ones. What this really looks like, actually, is from the other day. See how that's a midpoint? And then it joins over here. It looks like it's a mid-segment. I actually wouldn't say that because you can see right here AG and GB, they don't really designate those as the same. I don't know that G's the midpoint. I'm just going to write neither here. I really couldn't designate that as anything. The last one then is CF, and for CF, it does come out of the vertex, so it has one of our new relations, but it comes down here and it's perpendicular. All right, that's an altitude. Out of the vertex perpendicular to the other side. Now when you do the altitudes and you have an altitude coming out of each one of the vertices, they're all going to cross at a single point. That single point is called the point of concurrency, and it's called the orthocenter for the altitudes. And just like with the perpendicular bisectors, and really this happens anytime you do something perpendicular, you have options on where it might land. And this one, if it's an acute triangle, all the angles are acute, the orthocenter will always land on the inside of that triangle. If it's a right triangle, it's going to land on the triangle somewhere. So right here you can see I dropped that altitude, I dropped that altitude. Because it's a right triangle, they happen to be legs, and then I dropped this altitude, they all cross right here at the vertex of my right angle. And if you have an obtuse triangle, which means you have one angle that's obtuse, then those altitudes all end up intersecting actually outside of the circle, or outside of the triangle. All right, this is something that's on your homework, so pay attention closely. This is a little bit tricky problem. It says you have DF, and it has vertices at 1, 2. Okay, so let's go ahead and just start plotting these points. 1, 2 lands right here. 1, 6 is right here. And 4, 2 lands right here. And it's a triangle, so let's go ahead and join the sides and create this triangle. It says, what are the coordinates of the orthocenter? Okay, so that means I need to draw in the altitudes for this. Now I can freehand it, but you got to be a little bit careful because it's so tiny, it's not very accurate. So I guess the thing that should help us is that if you have perpendicular lines, they have opposite reciprocal slopes. If I'm trying to draw a line that's perpendicular, so for instance right here, I'm going to drop from this point perpendicular to this side. Okay, well if I'm going to make it perpendicular to this side, then it's going to have an opposite reciprocal slope to that side. So let's figure out what this slope is. So starting up here, my rise is 1, 2, 3. -4, run is 1, 2, 3. I have a slope of -4/3. Now if I want to drop an altitude to that segment, I'd have to have an opposite reciprocal, so that's going to lead me to a positive 3/4. And then I'm going to plot that. I'm going to take this vertex right here, because it's the one that's across from that side I just counted out, and I'm going to count from that vertex my rise and run. So I'm going to rise 3, run 1, 2, 3, 4, 5, right here. And then that is my altitude. Okay, I'm going to undo that, redraw that. That's kind of bendy. A little bit better. Okay. Now, on your homework, you're going to have some easier ones. You're going to have some trickier ones. That one, okay, sorry, I'm erasing one more time. I'm going to change the color of it so you can see that this is my altitude. All right, and then I have to have other altitudes. So that's the altitude coming from this vertex. If you think about what's the altitude coming out of this vertex, well, the opposite side happens to be a horizontal, so a vertical, straight down. There's the altitude right there. And I could do that from over here on this side too. Drop the altitude this way. They all intersect right here at that right angle. So what are the coordinates of the orthocenter? 1, 2. Those are the coordinates. Now we got lucky because that was a right triangle, but usually you're going to have to do that opposite reciprocal slope thing here at least once, and then maybe you'll get lucky and have a horizontal or vertical line to get your other one. And I did all 3. Really, if you just did 2, the 2 should intersect at the orthocenter as well. All right, give those a try. I did actually give you I gave you an extra graph in your notes so that you have something to graph those problems off Math Excel with. So use your notes for that. All right, the other thing that's going to be on your Math Excel homework assignment will be just getting familiar with those terms. Don't be afraid to use your little cheat sheet that I gave you that has all the different segments and all their points of concurrency. This one is asking for the centroid. The centroid matches up with the medians. So what I have to do is I have to find some medians and see where they intersect. When I look at this triangle, the medians, remember, go to the middle. So to the middle means this right here is a midpoint. So this would be a median. This one right here is a midpoint. So out of the vertex, that's a median. Now this one I don't have anything coming out of. I know I see a midpoint of D, but I don't have anything coming out of C, so I don't really have a median. So where do these two medians meet? At H. H is your centroid. All right, same idea on number 19 here, but I'm doing orthocenters. So those are altitudes. Altitudes come from a vertex perpendicular to the other side. From a vertex perpendicular to the other side. This next one I can't do because it's not perpendicular. So I just have these two altitudes. They intersect here at J. J is my orthocenter. All right, now I thought this was kind of fun to look at. I have all these points, and there's 4 different points of concurrency. They list them there. Circumcenter, incenter, centroid, and orthocenter. And what we did is we just kind of sketched what they look like. If I wanted the circumcenter, all right, that's perpendicular bisectors. So I'd find a middle here, and I would draw a perpendicular. I'd find the middle here, and I would drop the perpendicular. Find the middle here, drop the perpendicular, and look, oh, they all intersect at D. So the circumcenter is D. And we did that for each one of them. The incenter. The incenter is supposed to come from, well, I'm going to go ahead and just change colors. It's going to get kind of cluttery. Incenter comes from angle bisectors. So let's see if I can draw an angle bisector here. Angle bisector. Angle bisector. Okay, where do they all intersect? At B. So that's your incenter. Okay, let's change up again. Now we want centroid. The centroid goes to the midpoint. I'm sorry, it's the medians, and so it goes to the midpoint. So I already have my midpoint from earlier. There, and there are my midpoints. But now I have to come, instead of just making some random perpendicular line, it's going to come from the vertex to that midpoint. And you can see those lines all intersect at C. So that's your centroid. Orthocenter comes from your altitudes. All right, last one. I thought I'd erase. I'm just going to keep going. It's just pretty. Drop the altitude. That means straight down. Drop this altitude. Oh, this kind of almost looks like it's a right triangle, doesn't it? Drop this altitude. They all end up intersecting there at A. A is your orthocenter. All right, the end center in the centroid always end up inside the circle, but the circumcenter and the orthocenter sometimes are on it, sometimes are in it, sometimes are outside of the triangle. Okay, the last thing we have are our constructions, and we're going to construct both the centroid and the orthocenter, and then you'll have everything you need for to finish out your homework or your construction homework. Let's construct this in our notes for now, and then you'll come back later and you'll be able to do your construction worksheet. I'm going to start off to find the centroid. That means I have to find the medians. Okay, so the medians go to the middle. I'm going to need to find the middle of each side. So to find the middle of this, I'm going to do my perpendicular bisector construction. Perpendicular bisector construction looks like this. Put the point of the compass here, make that arc, put the point of the compass here, make that arc. Remember, you're stretching it up over halfway. And then you can draw that perpendicular in there. Now, we're going to have a lot of construction marks, and this is going to get pretty messy. So if there's something that you can shortcut with, it might be smart. So let me talk about some things. I really don't have to make this great big arc. You should probably remember that we really just want the little X's. So you don't need all of that. And then the other thing, I really needed just the midpoint. I don't really need this perpendicular bisector, so you wouldn't have to draw all of that. Maybe just make kind of a dash right there in the middle and make note of, oh, there's my midpoint. It lands here because what you really want is the median, and the median goes from the vertex to the middle. So that's your median right there. But to get the centroid, I have to do 3 of those. All right, so we're going to do that again. We're going to find the midpoint of another side. And that looks bad. I know that doesn't really look like the middle. I'm sure yours looks better. All right, let's do this side over here on the left. And I'm going to do my arcs, stretch my compass, put my point here, stretch over half, do your arcs above, below, go to the other side and do the same ones. Now, if you want to pause the video so that you can do that and then pick it up, please do that. Pause it as you need as we go. What I've got, though, when I line up my 2 X's, I get like this midpoint. And so to draw the median, it has to come from a vertex to that midpoint. So here's going to be my median right there. And then we're going to do it one more time. This side over here on the right, put the point of your compass here, stretch it over halfway, make an arc, go to the other point, do the same deal. You're looking to line those up and find the middle. That's terrible. I know that's not the middle. I'm trying to make my medians actually intersect in a single spot right there. Oh, look, here's my centroid. That's the centroid. That's the, remember, the center of gravity. Good balancing point. Okay, then the last one would be to get our orthocenter. This is actually a little bit trickier. Orthocenter are altitudes, and altitudes have to be perpendicular. I got to come up with a line coming out of this vertex here, perpendicular to this side down here. But I have to do it with all 3 vertices. All right, what this construction actually is the one we did previously where you're trying to get a perpendicular to a line from a point that's not on that line. So this is like my vertex, and then this is my opposite side. And remember how you did the arc down below, and then from those 2 points you did you made your X's and there was your perpendicular. That's what we're doing. All right, so hopefully this is going to work out okay. I'm going to put the point of my compass here, and I'm going to come down here and make an arc. Now what you're going to find is something like this is going to happen to you. At some point this is going to happen. You try to make this arc, and it goes way past the side of your triangle. That's okay. What you're going to find that you'll have to do, and don't freehand this like I am, but you'll get your ruler out, and you'll just have to extend the side of this triangle. Okay, so now I have this point, and I have this point. From those 2 points, I'm going to do my arcs above and below, stretched over half, there's an arc, there's an arc. Then do it from the left, there's an arc, and That's pretty bad. Can I undo that a few times? I'm going to have to undo that. I need this to be better than that. Because it's supposed to line up with, I'm going to do my arcs, it's going to look something like this. Because I need it to line up right here. When I line that, that vertex should go through both of those X's. And that right there is my first. I'm going to do that in a different color so it stands out. This is my altitude. Okay. This is bad when I try to freehand it. I apologize. Let's try again. I'm going to work from this vertex, and I'm going to put an arc down here. Now I'm freehanded. Mine looks great. If you're if you're doing it with your compass and you need to extend a side of that triangle, feel free to do that. I've got these 2 points. I'm going to do my arcs above and below, and then do it from the other side. And then you should be able to connect those, and they should all actually connect right through that vertex and your X's. Last one. I'm going to put the vertex of my compass right here and make an arc down here. Maybe extend a side if I need to. Now from these 2 points, put the point of your compass, arcs above, below, and then you're going to draw a line right through those, and it's going to go through your vertex and both of those X's, and it's going to end up perpendicular. Oh my gosh, undo, undo. That's terrible. It's supposed to go like right through there. See, now that's what I'm looking for right here. I'm looking for, did you get a triangle right there, or did it all intersect in one spot? It was supposed to intersect in one spot. I created a triangle even after I cheated on it a little bit. That's supposed to be one single point, the orthocenter. All right, I know it's kind of messy there. It's going to be messy for you too, I promise. That's okay. I kind of know what I'm looking for when I'm grading it, so don't start erasing all those ugly construction marks. I want to see them. All right, good luck.